We ask it to do everything these days, right? Write our code, brainstorm business ideas, heck, even compose poetry. It really feels like we're talking to a genuine intelligence. But how in the world did we get here? You know, the story behind this technology is way more dramatic and thrilling than you might imagine. So let's dive in. This is the origin story of modern AI.
Okay, so it all boils down to this one central question that's just fascinating, isn't it? We see what it does, but how did a machine, whose only job is basically to predict the next word in a sentence, somehow learn to reason, to create? I mean, where did this intelligence actually come from?
Well, the answer isn't just one single invention. It's actually a story of three, let's call them revolutions. Each one was this massive breakthrough that just completely smashed through a wall that had been holding AI back for decades. And our journey, it starts in a time when computers were, and I'm not exaggerating here, basically illiterate.
Right, so for the longest time, computers just couldn't get the most basic, fundamental thing about language: context. I mean, they could see the words on the page, sure, but the actual meaning? Totally lost on them.
So, the main approach back then was called bag of words. And yeah, it is every bit as clumsy as it sounds. Literally, imagine you take a sentence, you throw all the words into a bag, shake it all up, and then the computer just kind of peeks inside and counts what it finds. That's it. It treated our beautiful, complex language like a jumbled-up grocery list, completely blind to word order, and because of that, totally blind to meaning.
And here's the problem, plain and simple. To a bag of words model, a meaningful sentence like the one on the left is exactly the same as the pure gibberish on the right. They're identical to the computer. So by ignoring word order, it just completely destroyed the meaning. This was a total dead end. Something new was desperately needed. Okay, so the next generation of AI. This was a big step forward. These new models, they finally got it. They understood that word order is crucial. But, and this is a big but, in solving that one problem, they ran smack into a brand new one. A really, really bad one. A crippling bottleneck.
So these next models, you might have heard of them. They're called RNNs and LSTMs. Don't worry about the names. Just think of them as AIs that finally had a little bit of memory. And they worked sequentially. So they'd read word 1, then word 2, then word 3, in this super rigid step-by-step chain. Now, on the surface, that sounds logical, right? But it created two massive problems. So first off, they had terrible short-term memory. I mean, you give it a long paragraph, and by the end, it's completely forgotten what you were talking about at the beginning. But the real killer, the critical failure, was speed. This one-at-a-time process just couldn't be sped up. It's like you can't start reading word 20 until you finished word 19. And that meant training these things on the sheer amount of data on the internet was, well, it was physically impossible. AI had hit a hard engineering wall.
And then 2017 happened. A single research paper dropped, and it was nothing short of a seismic event for the entire field. This wasn't just some small improvement. No, this was a total game changer. It kicked off the entire era of modern AI as we know it. This, right here, was the moment everything changed.
The paper had this almost poetic title, "Attention is all you need." And what it introduced was a radical new architecture for AI called the transformer. It basically took that old, slow, sequential way of thinking and just threw it right out the window. It proposed a completely new way for a machine to read. At the very heart of this new transformer was a mechanism called self-attention. And the core idea was just so profound, but also so simple. Forget reading word by word by word. What if, instead, the AI could just look at the entire sentence, all at once? This simple shift allowed the model to instantly weigh the importance of every single word against every other word, finally unlocking a real deep understanding of context.
I mean, this was a monumental leap. Think about it. The old way was like painstakingly reading a book one line at a time. The transformer, though, with its attention mechanism, it was like instantly scanning the entire page at once, seeing all the key words, seeing how they all connect to each other. And this is what unlocked massive parallel processing. The scaling barrier that had stopped AI in its tracks, it was just shattered.
So with that speed bottleneck completely destroyed, the race was on. The question wasn't about who could write the cleverest algorithm anymore. Oh no. The new game was all about a massive, high-stakes bet on one simple, almost brute force idea. What happens if we just make these things bigger? Like way bigger?
And this bet led directly to the meteoric rise of the GPT models. In 2018, you had GPT-1, which basically just proved the concept worked.
Then, just 1 year later, GPT-2 came out and it shocked the world with how coherent it was. But then, in 2020, GPT-3 took a genuine quantum leap, and it revealed something truly astonishing about the nature intelligence itself.
And when I say a leap, I mean it was colossal. Look at this. GPT-3 wasn't just a little bit bigger than GPT-2, it was over 100 times larger. The number of parameters, and you can just think of those as the connections in the AI's brain, it just skyrocketed from 1.5 billion to a completely mind-bending 175 billion.
What they were doing here was a full-scale test of a big idea called the scaling hypothesis. And the theory was simple. If you just keep making the models bigger and you keep feeding them more and more data from the internet, they won't just get a little bit better at what they do. The bet was they would suddenly unlock entirely new, unforeseen abilities. It was a huge, huge gamble.
And the gamble paid off. Big time. The result was this incredible phenomenon called emergent abilities. Suddenly, complex skills like logic, math, even coding, they just appeared in the massive GPT-3 model. And these were skills that were totally absent in the smaller models before it. The AI wasn't just following instructions anymore, it seemed like it was learning how to learn. So let's take stock. By 2020, humanity had created this wild, untamed genius. GPT-3 was unbelievably powerful, incredibly knowledgeable, but it was also totally unpredictable and, frankly, unsafe. Remember, it was trained on the entire internet, the good, the bad, and the really, really ugly. And this presented the final, and maybe the most important problem of all, alignment.
Okay, here's the core of the alignment problem. The AI had only one goal: predict the next word based on what it saw on the chaotic, unfiltered internet. But you, when you ask it a question, you have a totally different goal, right? You want a helpful, honest, and harmless answer. And those two goals, they were dangerously misaligned.
So how do you fix that? Well, the solution was this really clever process called reinforcement learning from human feedback, or RLHF for short. The easiest way to think about it is like coaching an AI. So step 1, you fine-tune it on really good examples of conversations. Step 2, you have actual humans rank the AI's different answers, and you use that data to train a second, coach model that learns to spot what humans prefer. And then finally, step 3, you use that coach model to reward the main AI whenever it gives a good, helpful, and safe answer. You're basically teaching it good behavior.
And that's it. That's the final piece of the puzzle. The birth of ChatGPT, as you can see, wasn't just one thing. It was the convergence of these 3 huge, distinct breakthroughs. So let's put it all together.
So here they are, the 3 revolutions. First, you have the architectural revolution, the transformer, which smashed that speed bottleneck and made massive scale possible. Second, the quantitative revolution, of just scaling up, which proved that bigger models could develop incredible new abilities, like abstract reasoning all on their own. And finally, the alignment revolution, with RLHF, which solved the safety problem and turned that raw, wild genius into a helpful and responsible AI partner.
And you have to understand, every single one of these was absolutely necessary. They had to happen in this order. Without the transformer, you can't scale. Without scale, you don't get those magical emergent abilities. And without alignment, that incredible intelligence is just too dangerous and unpredictable to use. These 3 pillars, built one right on top of the other, are what make the tool we use today possible. So there you have it. That's the origin story. We've gone through the key breakthroughs, the big gambles, and the revolutions that led to its creation. We now know how it was born. But, the next question is maybe even more fascinating. How does it actually think? Join us next time when we go inside the mind of the machine.